The objective of this video is to practice simple density calculations. What I mean by simple density calculations is that using this density equation as it is. You are all familiar with this density equation. Sometimes you do need to rearrange this setup. So what I'm going to show here is using this equation as it is without doing any rearrangements. Let's look at our first example. A saltwater solution has a mass of 11.29 grams and a volume of 10.4 milliliters. What is the density of this solution? It is always easier to identify the correct information if you try to extract the information out. Now this description can be a little bit wordy, so when you try to do the calculation, always try to extract the information out. Here you can see mass. Now what you can do is take that information out, and then we have volume mentioned here, and take that aside as well. And what you find here is that asking to calculate the density. Now it's very clear what you have and what you are asked to do. Now let's take our density equation. Now when you compare this equation with the information you have taken out, you can clearly see that you can substitute this mass value in this equation over here and in the volume over here. Now we have plugged in the relevant information, the mass 11.29 and the volume. Now we are going to get this answer if you do the calculation from a calculator. So what I have shown here as a dotted line is that you will see an endless set of numbers, and then focus on this unit. You can see what we have done here. We have divided the mass by the volume. So I have continued with the same units as it is. We are dividing the mass grams by the volume milliliters. Now is this our final answer? Is this how we are going to report this answer? No, we have to report this answer to the correct number of significant figures. So how can we figure out the correct number of significant figures? To do that, we have to look at the number of significant figures we used in our actual calculation. Here you can see 4 significant figures. If you are not familiar with significant figure rules, go check my other video on significant figures. And then in this number, you will find 3 significant figures. Now look at what kind of mathematical operation we have done here. What we have done is division. So when we divide, you know what we have to do in the significant figures. When we do a division, the number of significant figures in our final answer should match the minimum number of significant figures that were in our actual calculation. That means our final answer should have 3 significant figures. Why? Here we have 4 sig figs, and over here we have 3 sig fig. If we have an operation multiplying or dividing, our final answer should have the minimum number of sig fig. So that means from this answer we have to choose the first three sig figs and report the final answer to only 3 significant figures. Now what are our first 3 significant figures? Now you can see these 3 are going to be our first 3 significant figures. That means everything else beyond this we are going to drop. So what is the first digit that we are going to drop? This is the first digit that we are going to drop. 5. Now you know the rounding off rules. If you have the first digit that you're going to drop as 5 or larger, you're going to round up. That means what we find here is 5, so you can increase the value of this number by 1. So that means we are going to report this number as 1.09. Why we did it like that? Because the first digit we are dropping is 5 or greater. And this is our final answer with the correct number of significant figures and correct units. Let's go to our next problem. A rectangular block of copper metal weighs 1,896 grams. The dimensions of the block are 8.4 centimeter by 5.5 centimeter by 4.6 centimeter. For this data, what is the density of copper? Now, as I mentioned earlier, try to extract the information out from this wordy description. Now, you can clearly find the mass of this block. Now, in this description here, it mentions density. So you know you have to do some sort of a density calculation, and it is asking you to calculate the density. That means density is an unknown factor. It is the thing you have to calculate. What about volume? It doesn't mention anything about volume at all. But what you see in this description is the dimension of a block, a rectangular block. So that means this is what you have. You have a rectangular block and it has these mentioned dimensions. And you know how to calculate the volume of a cubic object. Now let's go ahead and try to calculate the volume of this block. The volume of a block is calculated using length multiplied by width multiplied by the height. Here it doesn't mention which length is which one, but anyways, you know how to calculate it. You simply have to multiply these three with each other. So 8.4 multiplied by 5.5 multiplied by 4.6 centimeters, you get this number, 212.52 cubic centimeters. Remember the units. You have centimeters multiplied by centimeters, again multiplied by another centimeter. So what your unit is going to be cubic centimeters. Even though this description did not mention the volume, now you have actually calculated the volume. Now we know what the volume is and the mass is. Now we can easily calculate the density. What you need to do is get your density equation and substitute this mass value and the volume value. Now I'm going to substitute the mass value and the volume value, and I'm going to do the calculation, and I'm going to get this numerical value with the proper units. Note here what kind of units I have used. In the description, I had the units of grams, and from this calculation, I got cubic centimeters as my volume units. So in this particular description, it does not ask for specific type of unit, so we can go ahead and report our final unit as grams per cubic centimeter. If it asks you to convert this unit into something else, then you have to do it. Now, is this your final answer? No, you have to report it into the correct number of significant figures. Now let's check the number of significant figures in our operation. In this number, you can find 4 significant figures. How about this 212.52? What is the correct number of significant figures here? Now this is a problem. Why? We did not directly measure this volume. This is a calculated value. In this figure, you can see 5 non-zero digit. In a more regular sense, if you have 5 non-zero digits, you will go ahead and say it is 5 sig figs. But can we say we have 5 sig figs here? No, we cannot, because this is not a direct measurement. This is a value indirectly obtained by using this calculation. So these are our actual measurements. Now you need to recall why we actually use significant figures. The reason we use significant figures is because of the uncertainty that arises with measurements. So which hold the significant figures? The measurement. So these are your actual measurements. So you have to focus on the significant figures of the measurements. Now if you consider this set of numbers, you will find all of these numbers holding only 2 sig figs. Therefore, even though you see 5 non-zero digits in this number, it holds only 2 significant figures. Only 2 significant figures are allowed in this number, and these first 2 are the only 2 sig figs that's allowed. However, we do not round off in the middle of a calculation. Keep in mind, we always round off at the very end. So even though this hold only 2 sig fig, we continue with the full number and we do the rounding off at the end. So that means what we should have here is only 2 sig figs. Now these are our allowed 2 significant figures. Now we are going to round off this answer to 2 sig figs. So we start dropping from here. Now this is the first digit we are going to drop, 2. Number 2 is smaller than 5. So that means the digit right in front of it, this one, number 9, is not going to change, because the first digit we drop is smaller than 5. Now this is how we report the correct answer with the correct number of sig figs and the correct units, 8.9 grams per cubic centimeter.